Hello, welcome to my presentation on value engineering regarding Intermodal Transit Center in the city of Hercules in the state of California. Before we begin our presentation, or specifically my presentation, let me introduce myself. My name is Mikhail Omar. I am a student from Diponegoro University of Indonesia. So let's begin. So the agenda, we first have the introduction, proposed project, scope, study, constraints and decisions, issues, project analysis, ideas, and summary. So let's first introduce ourselves to the area itself. The city of Hercules, California is a city located within Contra Costa County, California, which has a population of approximately 26,016 people based on 2020 consensus by the UNCB. In regards to transportation, the area where the city of Hercules is located has an abundance of transportation options ranging from highways for land-based vehicles, bus transportation, rail services, and air travel. This is the proposed plan for the value engineering case study. The project proposes the construction of a new Intermodal Transit Center, or ITC for short, alongside roadway improvements and supporting facilities. Plans to improve the operations of the existing rail line includes the realignment of the Union Pacific Railroad, shown as UPRR track, to the east, and a new railroad bridge is planned to be constructed over Refugio Creek. The project is intended to be constructed using federal funding, hence why the Federal Trade Administration acts as the head agency for the project. So here are the images. The one on the left, on the top left, illustrates the proposed. It's the idea or what's planned to be constructed. And on the bottom right shows the current progress from November 2023. As you can see, not much progress. Let's continue. Scope, study, constraint, and decision. The scope by the value engineering team is about conducting a thorough analysis and review of key project issues and conceptual designs using a multidisciplinary functional team. The project issues. First day of the study includes a site visit which highlights 4 issues. There are actually more than 4 issues, but for simplicity's sake, I'll only mention 4. The limitation of construction, a lot of earth moving to stabilize land, and more horizontal rail track curvature that could present an issue for railroad flagging. Project analysis. After the conclusion of the site visit, the value engineering team reviews using 3 different elements and functions: cost model, functional analysis, and the FAST diagram, which stands for Functional Analysis Systems Technique Diagram. Cost model prepares a cost model based on the baseline cost estimate provided by the project team in order to identify major construction elements or trade categories alongside estimated project costs. The function analysis aims to transform project elements into functions, which allows the value engineering team to shift away from original ideas and take it towards a more functional concept of the project. Lastly, the FAST diagram, which acts to arrange functions in logical order so that when read by somebody, it can be answered with a how and whys. The idea. So throughout the project itself, the value engineering team, during their study, generated over 75 ideas that they meticulously evaluate based on project-specific attributes and supporting functions. Out of those 75 ideas, only 11 were found to be of significance for the project. So let's start with the first one, the railroad realignment. The recommendation where new bridges are constructed by Union Pacific themselves alongside construction and placement of the new MT0 track in its final alignment. It is estimated to be able to save $500,000 from the project. Second idea, fill walls. A recommendation where ground improvements are done using MSE or segmental block walls and replace the original concept of pile-supported cantilever retaining wall along bayfront project area. This project is able to save a couple million from the project. Idea number 3, shorter promenade wall, a recommendation that aims to decrease the width by having an upper portion of grade change to become a slope or have a certain grade difference between promenade and EBRP trail with slope or steps in between. The project is predicted to be able to save approximately $47,000. Idea number 4 is the center platform, a recommendation that aims to utilize 10-inch post-tension cast-in-place concrete with topping on 2 grade beams to control differential settlement and cracking. This recommendation is calculated to be able to save $600,000. Idea number 5, pedestrian guardrail revision. Unlike the previously stated ideas, this one and the next one has 2 different options. Option A replaces the glass guardrails with steel cable guardrails. Option B widens the ramp to eliminate gap between ramp edge and structure. The recommendation is calculated to be able to save $0.48 million. Idea number 6, recommendation has 2 options as well. The reduction of wind turbines from 12 to 10 or from 12 to 8. The recommendation saves approximately 0.39 million. Saves approximately 0.16 million for option A and 0.32 million if one were to choose option B. Idea number 7, modular construction. A recommendation that aims to use braced frames in place of moment-resisting frames to resist lateral loads wherever possible. Using braced frames will allow the framing to be assembled into modules that can be craned into place to speed up construction. This recommendation is calculated to be able to save $0.36 million or $360,000. Idea number 8, restraining guardrails, that aims to add a new restraining guardrails through the platform area of the station. Because this particular idea has no initial idea from the project itself to compare with, it will increase the project by $0.11 million or $110,000 if it were to be implemented, of course. Idea number 9, park amenities. A recommendation that aims to use stamped or scored colored concrete to delineate promenade that will maintain the aesthetic, respect the design intent, and enhance the use of the location. It aims to provide alternative site furnishings that respect the design intent, aesthetic, and performance while reducing the unit cost. This recommendation is calculated to be able to save $0.46 million or $460,000 approximately. Idea number 10, basement elimination. A recommendation that aims to combine recommendation number 1 and number 2, which allows for simplification of wall construction and backfills prior to building construction. This recommendation is calculated to be able to save approximately $0.41 million from the initial cost of $0.87 million down to $0.46 million if it were to be implemented. So we'll go to idea number 11, landscape items. A recommendation that aims to use native plants instead of non-native plants. The recommendation seeks to cover 35,710 square foot of land at a cost of $3 per square foot in shrub/ground cover and the usage of organic mulch to fill in 197 cubic yards at a cost of $45 per cubic yard. The recommendation is calculated to be able to save approximately $0.13 million or $130,000. So we finally end up with the summary. In the summary, the value engineering team prepared a cost model for the baseline cost estimate that was provided by the project team. The following conclusions were noted, such as the fact that the train station accounts for 32.3% of the project total, the retaining wall accounts for 26.6% of the total, the realignment of the railroad accounts for 8% of the project, while relocating the gas line and fiber optic utilities account for nearly 8% of the project total. The table on the right shows the cumulative and the cost-saving measures that are able to be done. And that is the summary of my presentation. Thank you for your attention and have a great day.